Hello Collins Cobras, this is Mrs. Hernandez and I'm here to talk to you today about histograms. Histograms are a way to display a set of data, and the way that they work is by showing data in intervals or ranges of numbers. They are similar to bar graphs, but each bar touches the other. So here's an example of a picture of a histogram, and you can see that the bars are all touching. There are no gaps or spaces in between. And they are similar to a dot plot because they represent the overall spread and shape of the data. One way that they're different from bar graphs, though, is on a bar graph, the information here on the x-axis would be categories instead of intervals. So that's a big difference between bar graphs and histograms. And examples of sets of data that are good for histograms are when we're talking about decades or big periods of time. When we're talking about age ranges would be another example. And the example that we're about to talk about are scores. So we're going to use this histogram that they've given us to answer these questions. How many scores were included in the data set? Well, if we look here on the y-axis, it's labeled with numbers of scores. So each bar represents how many people fell into that interval. And what we want to do is add the total number of people that participated in this survey. So from interval 1 to 5, or ACT score from 1 to 5 points, one person scored in that range. One person also scored in the range of 6 to 10 points. 17 people scored in the range of 11 to 15 points. 34 people scored in the range of 16 to 20 points, and so on. So we can add all of these up. I went ahead and labeled how many people were represented in each of those bars because it was a little difficult to read. And if we add all of those up, it's going to be 1 plus 1 plus 17 plus 34 plus 28 plus 16 plus 3. We would get 100. So a total of 100 people are represented on this histogram. Then it says list the number of scores for each range. So all we need to do take these labels on the bars and put them into the list. So one person scored 1 to 5 points, one person scored 6 to 10 points, 17 people scored 11 to 15 points, 34 people scored 16 to 20 points, 28 people scored 21 to 25 points, 16 people scored 26 to 30 points, and 3 people scored 31 to 35 points. Alright, so now we can answer these questions using the information in this histogram. Which range of scores represents 17% of the data? Well, what we know about percent is that it means out of 100. So 17% is equivalent to 17 out of 100. And the interval 11 to 15 had 17 people fall into that interval, which would be 17 out of 100 or 17%. So our answer is the interval 11 to 15. Question 2 says, what percent of the scores are included in the 21 to 25 range? Well, we know that this survey is out of 100. And the numerator here is going to be the number of people that scored in the 21 to 25 range, which was 28 people. But the question asked us for an answer as a percent. So our answer is 28%. Question number 3 says, what two ACT score ranges make up more than 60% of the sample? So if we take a look at 34 out of 100 and 28 out of 100, That would be 34% and 28%. 34% was interval 16 to 20. 28% was interval 21 to 25. We would get 62%, and we were looking for more than 60, which is 62. So our answer is interval 16 to 20 and interval 21 to 25. Okay, and question 4 says, how does the number of scores between 11 to 15 compare to the number of scores between 16 and 30? So for interval 11 to 15, 17 people fell into that interval. For interval 26 to 30, 16 people fell into that interval. So what we can say, because it's asking us to compare those, what we can say is that they are similar. And we can draw that conclusion because the difference between 17 people and 16 people is only 1. They are similar. A similar number of people fell into this interval as did this interval. Question 5 says, below write 3 statements about the graph, 2 that are true and 1 that is false. You can definitely get creative here and come up with your own answers. But I'm going to go ahead and write some as examples for you. So one thing that's true about this set of data is that there is a peak at interval 16 to 20. Another thing I can tell is because this is the peak of the data, that means that it's also the mode. So the mode of the data is interval 16 to 20. And a false statement about this data would be that the data is skewed. This data is not skewed. It's pretty symmetrical. So if I look here at the peak, the data that falls on the left of the graph and the data that falls on the right of the graph are pretty similar. It's not exactly the same, but it's similar enough to be symmetrical data. So it would be false to say that the data is skewed. All right, so let's move on to this page. We're going to be using this histogram that represents library patrons to answer questions 6 through 9. Determine the total number of library patrons surveyed. So what we want to do is find out how many people fell into each interval and add them together. So for the interval 10 to 19, that's 8 people. 20 to 29 was 15 people. 30 to 39 was 6 people. 40 to 49 was 2 people. 50 to 59 was 7 people. And 60 to 69 was 12 people. And again, I'm getting that information here from the y-axis, and you can even count the tick marks. And that's how I found 8. This one was shaded up to 15, and so on. And if we add those together, we can see that a total of 50 patrons participated in this survey. Okay, our next question says, how many library patrons are younger than 30? So we would want to look at the intervals and find the ones that represent younger than 30. So that would not include 30 to 39 because 30 is not younger than 30, but it would include interval 20 to 29, which is 15 people, and it would include interval 10 to 19, which is 8 people. So that would be 23 patrons that were younger than 30 that participated in this survey. Okay, the next question asks, based on the information in the graph, which two age ranges are responsible for exactly 40% of the patrons? So I want 40%. But I don't have any percents to work with, so I'm going to start out with a fraction. And I know that I have a total of 50 people. So I want to know 40% is equal to how many out of 50? And that's going to be 20 out of 50 is equal to 40%. I can also tell that that's true because 2/5, which is a benchmark fraction, is equivalent to 40%. So I need to find two intervals that would add up to be 20 out of 50. And so when I'm looking at my information in my histogram, I can see that 8 and 12 would give me a total of 20 people out of 50 people. So interval 10 to 19, which is 8 people, and interval 60 to 69, which is 12 people, is 20 out of a total of 50. So these are the two intervals that represent 40% of the data. And question 9 says, based on the information in the graph, in which age range are 30% of the library patrons? So I want to start out the same way I did before. I want to find out a fraction that's equivalent to 30%, but I want that fraction to have a denominator of 50. And that would be 15 out of 50. So then I want to see which interval represents 15 people, and that's interval 20 to 29. Okay, so next let's take a look at this histogram that represents the distance of runners, distance that people ran. How many runners run between 3.0 and 4.9 miles each week? So if I look at that interval, this is the one I'm talking about right here. There are 8 people represented in this bar of 3.0 to 3.9. But I actually want to go all the way to 4.9, which would include this bar as well. And there are 12 runners in this bar. So within this range, 3.0 to 4.9, there are 20 runners. Okay, my next question says, how many runners run less than 4 miles each week? So then I need to look at which intervals are less than 4. It's not going to be 4.0 to 4.9, but it's going to be every interval before that. I already know there are 8 people in this interval. I can see that there are 10 people in the interval 2.0 to 2.9. And then 5 for 1.0 to 1.9, and 5 from 0 to 0.9. So now I need to take all of the information in these intervals and put them together. So 28 runners run less than 4 miles each week. And then our last question says, which of the following statements best represents the data above? 25% of runners surveyed run 4.0 to 4.9 miles each week. Well, if I add up the total number of people that participated in this survey, there are 40. And in the interval that we're talking about, 4.0 to 4.9, there are 12 runners. This fraction is equivalent to 3/10, which is equivalent to 30%, not 25%. Statement B says 1/3 of the runners surveyed run 2.0 to 2.9 miles each week. So again, I'm going to use this total of 40 because there are 40 people that participated in the survey, and in the interval that I'm talking about, 2.0 to 2.9, 10 people participated, which is equal to 1/4, not 1/3. Statement C says 1/5 of runners run 3.0 to 3.9 miles each week. So once again, a total of 40 runners, and the interval we're talking about, 3.0 to 3.9, would be 8 runners. If I simplify that, I will get 1/5. So I can see that this statement is true, but let's go ahead and evaluate statement D. The number of runners surveyed who run less than 1 mile is equal to the number of runners surveyed who run 3.0 to 3.9 miles. So in the interval less than 1 mile, the only interval that meets that requirement is 0 to 0.9. 5 people fell into that range. For interval 3.0 to 3.9, 8 people fell into that range. 5 is not equal to 8. So again, that's an untrue statement, which makes C the correct answer. I hope you have a fantastic day. Don't forget to do your practice page after this, and see you next time.